Okay, so with this question, we do not have an equation written in standard form or a function written in standard form. So we need to do that. Now, this negative out front is equivalent to having a coefficient, and that means we do need to factor before we complete the square. So I'm going to focus on completing the square for a moment. We'll have f of x. I'm going to factor out my negative. So x squared, I'm going to change my sign of the middle term, and I'm going to put my empty space here. And then because the 5 is outside of the parentheses, it's not affected, so plus 5. And I'm going to add, because this one is subtracting, right? Whatever goes in that space. So coefficient-wise, it is just a 1, but we have to account for the number value, right? We still have to make sure, and we can always check after we're done, we still have to make sure that this is equivalent to the original value. So we're going to take this -2, we're going to divide it by 2 and square it. That's -1 squared, and that's 1. And I do want to see work for this, right? I know that apps like Photomath and other, that kind of solve this for you have really weird ways about going about this, and they usually just write a number in. I don't want to see that. I want to see you solving for this value. Okay? So this is going to give us, we'll have f of x, we'll have negative x minus 2, not 2, we'll have x minus 1 all squared, plus 5 plus 1 give us 6. So this is in standard form. From here, we can kind of proceed as we did before. We have a is equal to -1. A is -1, which means it's a negative value and we face down. We also have values for h, which is 1, and k, which is 6. Again, remember h is the weird one. It has the weird sign. So this means that our vertex is going to be 1, 6. So again, let's graph that. So we have our vertex here, right? We also have an axis of symmetry. And we can see this is the line, x is equal to 1, so we'll add that to our list. Okay, so let's work on some of our other components. Let's look at our y-intercept. Okay, so the y-intercept, again, we're looking at f of 0, and again, I would be flexible. We have these two equivalent formats of our function, and I'll point out that original format, if we plug 0 in, you get -0 squared plus 2 times 0 plus 5, right? Which means that's a 0, that's a 0, and we're just left with 5. So that's an ordered pair, which would go here, right? And we can label that, or we can mimic that on the other side, right? It's just one space from one side to the other. So this would also be a point on our axis of symmetry, right? We get it or on our parabola because of the axis of symmetry. We kind of get it for free. Okay. How about x-intercepts? So x-intercepts. That is where we say f of x is equal to 0. And again, we have flexibility. You can plug this format right here in. I actually might take my -x squared plus 2x plus 5 and set that equal to 0. The reason why is this might allow me to factor. And if not, then I at least will know it's quadratic. So I think you kind of have options here for what you prefer. I'm actually looking at this and seeing it doesn't factor nicely. So, maybe I will stick with the original format. And some of that, again, it's stuff we want to learn as math students, right? What makes the most sense? What's kind of the best path or option for us to take? So I'm gonna actually ignore this one, and I'm gonna go with the negative. x minus 1 squared plus 6 is equal to 0. So I'll move my 6 over. Negative x minus 1 squared is negative 6, and we'll multiply both sides by negative 1, or divide, either way. You've got x minus 1 squared is 6, and then we would square root both sides. And that's why we would have had to use the quadratic formula here anyway, right? If factoring wouldn't have worked out cleanly. So you get x minus 1 is plus or minus square root 6. And then you move your 1 to the other side, 1 plus or minus square root 6. So let's actually find those values. So if you're looking at 1 plus the square root of 6, that is approximately 3.449. If you look at 1 minus the square root of 6, that is approximately negative 1.449. Okay? So just under 3.5 and 1.5, or negative 1.5. So here's 1, 2, 3, 4. So maybe right about there. And then this would be negative 1, maybe right about there. Right? And you can see spacing-wise, those still need to have symmetry with respect to that axis of symmetry, right? So if they don't look balanced, then something went wrong with our math a moment ago. This is a great one, though, because we have a lot of points, right? So we don't have to search for any extra points or anything like that. So we can sketch this in. All right. There you go. See you in the next one.